In this video, we will learn about the concept of differential equations, what exactly is a differential equation, and how do we solve a differential equation. Let's first go to the basics of integration. We know that if we integrate a variable, an algebraic term, the power is increased by 1 divided by a new power plus a constant of integration. This is called indefinite integral. But when we have limits such as a and b, what happens is that after integration, the limits are plugged in. This is the upper limit. This is plugged in first. This is the lower limit. This is plugged in later, and there is a negative sign in between. And what we get is the evaluation of this integral, and this is known as definite integral. In definite integral, the c cancels off. The constant of integration disappears. We also know that dy by dx is known as the gradient function. And we know that if we integrate the gradient function, what do we get? We get equation of the curve. So let's start the concept of differential equation from this point. For example, it is given that dy by dx is 2x plus 1 and the curve passes through the point 0, 1. And we are asked to find equation of curve. So what we do is that we write dy by dx is equals to 2x plus 1. And all of a sudden we write y is equals to integral of 2x plus 1. Now why do I say all of a sudden? Because in basic integration the logic is not explained. Now let's integrate each term. 2 remains as it is. Power of x is 1. The power is increased by 1. Divide by the new power. This constant 1 becomes x plus a constant of integration c. Let's simplify it further. This is 2 at the top, 2 at the bottom. It cancels off and we are left with x squared plus x plus a constant of integration c. Now we know that the curve passes through the point 0, 1, which means that when x is 0, y is 1. So plug the values where it belongs. 1 equals to 0 square plus 0 plus c, which gives us the value of c as 1. In other words, we get the equation of the curve as y is equals to x square plus x plus 1. This is the equation over here, and we found the value of c and we wrote the value of c over here. That's the equation of the curve. Now let's do exactly the same question. Given that dy by dx is equals to 2x plus 1 and the curve passes through the point 0, 1. And the question that is asked is find equation of curve. Now we will do it from a different perspective. What we will do is that we will write dy by dx is equals to 2x plus 1. And this dy and dx can be moved around. So dy is equals to 2x plus 1 in brackets multiplying with dx. That is the first thing that we did. The logic is write everything in x with dx and everything in y with dy. Since nothing is there, let me write a 1. So 1 is written with dy and 2x plus 1 in brackets is written with dx. dy by dx is known as differential, and any equation with the differential with the gradient function is known as differential equation. So this is the beginning of differential equation. The second step that we did was separating the variables. We are writing x terms with respect to x. We are writing the constant, since there was no y term as such, with respect to y. Now what we do is that we integrate both sides. So 1 dy, this is 2x plus 1 multiplying with dx, and we are integrating both sides with respect to their corresponding variables. Left hand side is with respect to y, right hand side is with respect to x. When we integrate 1, it becomes y. When we integrate 2x plus 1, we integrate it individually, 2x square over 2 plus x plus c. This is what we term as the general solution of differential equations. So this is the solution of differential equation in which c is not yet found, and we call it the general solution. What's the next step? The next step is, we know that it passes through the point 0, 1, which means when x is 0, y is 1. Let's plug it in. This 2 and this 2 cancels off. 1 is equals to 0 square plus 0 plus c, which gives us the value of c is equals to 1. The values of x and y, which enables us to find the value of c, this is known as boundary conditions. And once c is found, what we do is that we write the final equation as y is equals to x square plus x plus 1. This is called a particular solution of differential equation. Now let's go through it step by step. The question was the same as before, like the basic integration question. The gradient function is given. Curve passes through the point 0, 1. Find the equation of the curve. The very first thing is that we realize that any equation in which the gradient function is given, this is now termed as differential, and an equation with the gradient function is a differential equation. The second step is about separating the variables. The x terms goes with dx, the y term goes with dy. Integrate both sides with respect to their corresponding variable. Left hand side with respect to y in this particular question, right hand side with respect to x in this particular question. And then we proceed. Now a question arises, that is, there are two integrations happening. They both have their constant of integration. What we do is that we simply write one constant of integration, which is basically a subtraction of these two. So now we have y is equals to x square plus x plus c. We plug in the boundary condition and we evaluate the value of c. Till the step when c is not evaluated, this is known as general solution. Once c is evaluated and we plug in the value of c, what we obtain is the particular solution of differential equation. So this is the beginning of differential equations. Now let's try out some more questions. dy by dx is x over y. First of all, this is a question of differential equation. Why? Because it has the differential dy by dx. dy remains on the left, x over y as it is, and dx goes on the right. The second step, this y has to be transferred to the left because dy is over there. Y dy is equals to x dx. Now the step of separating the variables is all completed. What is the next step? Integrate both sides with respect to their corresponding variables. When we integrate y, we get y square over 2. When we integrate x, we get x square over 2 and an overall constant of integration c. Let's simplify a bit further. Let's multiply the equation throughout by 2. So what we get is that y square is equals to x square plus 2c. And this is the general solution of differential equation. Let's try out one more question. Something like dy by dx equals to x cube over y. Y goes with dy, x cube goes with dx. Integrate both sides. Y after integration becomes y square over 2. X cube after integration becomes x4 over 4 plus a constant of integration c. Let's multiply throughout by 4. So when we say multiply, we definitely mean both sides of the equation. So what we have is that y square over 2 multiplying with 4, x4 over 4 multiplying with 4, and c multiplying with 4. So we have 2y square is equals to x4 plus 4c. This is again the general solution of differential equation. One last question for this particular video. Dy by dx is equals to x square plus x plus 1 divided by y square. Y square dy, that is x square plus x plus 1 in brackets multiplying with dx. Integrate both sides. Y square after integration becomes y cube over 3. X square becomes x cube over 3. X becomes x square over 2. And 1 becomes x plus a constant of integration c. In this particular question, multiply both sides by 3. And this is just for simplification purposes. So what we have is y cube over 3 multiplying with 3, x cube over 3 multiplying with 3, x square over 2 multiplying with 3, x multiplying with 3, and constant of integration multiplying with 3. So therefore we have y cube is equals to x cube, 3 over 2 x square plus 3x plus 3c. Again, this is the general solution of differential equation. So what have we learned in this video? Any equation with dy by dx in it is known as a differential equation. The very first step is about separating the variables, and once the variables are separated, it's integration on both sides, and then we first go towards the general solution. And if boundary conditions are given, what are boundary conditions? Values of x and y. We can also obtain a particular solution of differential equation.